Hi everyone, this is Mrs. GA, and today we're going to be graphing the sine function. All right, I have a quick warm-up for you guys, so please pause the video and give it a try. All right, so go ahead and check your answers here. So you can see the values that I picked for x. I will call them like quote-unquote nice values. Like you'll notice that I picked pi over 6 and not pi over 3, just because it's a little bit easier for us to plot 1/2 than root 3 over 2. So you can see when I find these values, really we're just creating the parent function for sine of x. So you can see that our sine graph actually looks kind of like a wave shape. So we start at 0, we go up to 1, back to 0, down to -1, and you can see that by the time we've returned to 2 pi, we've kind of completed that cycle and it looks like we're about to start again. So this is just one portion of our sine graph, and actually our graph will just continue this pattern infinitely to the right and to the left. So this is what our parent function looks like. So there's a few pieces of vocabulary you need to know when we're graphing trig functions. First is the word period. So the period is the horizontal distance of one full cycle of our function. So you can see in that in the warm-up, we can see that it completed the cycle by 2 pi. So the period of sine is 2 pi, at least for the parent function. So you'll see depending on which function we're working with, the period may be different, and especially if there are transformations, the period can change as well. The next word we're going to be using today is amplitude. So by definition, amplitude is the vertical distance from the midline of our graph to the maximum or minimum of the function. So it's really half of the total distance because, again, it's from the midline to up to the max or the midline to the minimum. And then last is the term phase shift. So phase shift is simply a horizontal translation, so it's a shift left or right. But when we're working with trig functions, we call them phase shifts. It's not any different besides the vocabulary, what we call it, but just know that if you ever hear the term phase shift, it just means a shift left or right, a horizontal translation. Okay, so let's go back and look again at the parent function for sine of x. So you can see on the right here is what you guys just graphed, and this graph actually shows 2 full periods of sine. So again, it just kind of repeats infinitely to the right and left. So one thing to note, again, is the period is just the horizontal distance it takes to complete one full cycle. So for sine, or the parent function of sine, our period is going to be 2 pi. That's how long it takes for sine to repeat itself. Now remember, amplitude is the distance from the midline to a max or minimum. So in this case, you can see that our midline is just the x-axis, and our maximum value is 1 and our minimum value is -1. So that distance from midline up or midline down is the amplitude, which in this case is 1. So for our parent function, the amplitude is 1. Our domain, well, you can see that it's going to go infinitely to the left and right, so it's all real numbers. But you can see that our range is restricted. It bounces between -1 and +1, including both, so it's -1 to 1. Now, today we're going to be graphing functions that have transformations, so you might see maybe a negative out front, so that reflection over the x-axis. You may see a vertical stretch, you may see a horizontal stretch or shrink, and then you may see, remember, a phase shift or a horizontal translation, and we also may see a vertical translation. So I just want to talk about what these different transformations affect in terms of our graph for sine of x. So let's start with A, so that stretch or shrink. And this is a vertical stretch or shrink. So if it's a vertical stretch or shrink, it's going to affect the y values of your graph, which is how high or how low it goes. So if the y values of your graph are affected, that's going to affect the amplitude of your graph. And in fact, the amplitude of our graph is going to simply be whatever that a value is. So if the a value is 1, so maybe you don't see a stretch or shrink, then the amplitude is 1. But if maybe the A value is 2, so there's a vertical stretch by a factor of 2, that's going to be our amplitude. Remember, the negative and the A value are two separate transformations. Our amplitude will always be positive. Now let's talk about B, which is that horizontal stretch or shrink. Now notice in here it is factored out from the rest of our horizontal transformation. So remember, if you see a B value, it needs to be factored out if there's also a horizontal shift. Okay, so the B value, as we know, is a horizontal stretch or shrink. And remember, the stretch or shrink is by the factor of the reciprocal of B. So if we're stretching or shrinking horizontally, that's actually going to affect, well, it's going to affect your X values, which will affect the period, right? Because the period is the horizontal distance that it takes to complete a full cycle. So if we're affecting the horizontal distance or the X value, it will change the period. And there's actually, it's a quote unquote formula for the period of sine, but really it's just understanding that this is a stretch or shrink factor by a factor of the reciprocal of B. So the period is just going to simply be 2 pi, which is the original period, divided by B, whatever value you see here. And again, really we're just taking the original period and we're multiplying it by the reciprocal of our stretch or shrink factor. So just remember, period has to do with horizontal distance. And so if there is a horizontal stretch or shrink, it will affect the period. And the length of the period will always be 2 pi times the reciprocal of B, so 2 pi over B. Now let's talk about H. So remember, H is a horizontal translation, so shift left or right. So this is going to be a phase shift. But again, it's just a transformation, shifting your graph to the left or right, but we do call it that phase shift. And then this, the K value, of course, is a vertical transformation, so it's a shift up or down. And this will affect where the midline of our graph is. So if we're shifting up, then our midline is going to go up. And if we're shifting down, then the midline will go down along with the rest of the graph. Okay, so we're going to first try graphing these functions using a table of values. This is just one way we're going to learn how to graph today, but we'll start with this. When we're using a table of values, we're going to first look at our function, and we're going to pick some key points from our parent function, which is just sine of x. You could pick whatever key points you want, but I would recommend 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. So those are just some of the values from the parent function that you guys graphed in the warm-up. And again, really, if you have these values, it will create a very accurate graph, and we can kind of, just connect the points in a shape that we know our sine graph makes, which is that wave shape. So we're going to start with these points. Notice it does say to graph 2 full periods, and this will just be 1 period, so we're just going to have to replicate it again, but this will give us a good start. So now I need to look at the transformations I see in the graph. So the first thing I see out front is a vertical stretch by a factor of 3. So that's going to triple all of our y values. So I'm going to take all my y values and I'm going to multiply them by 3. As we talked about in the last slide, it will also affect the amplitude. So our amplitude in this case is going to be 3. Now here you can see that we also have a horizontal shrink by a factor of 1/2. So that means all of our x values are going to get divided by 2 or multiplied by 1/2. It will also affect our period. So remember, we take the original period, which was 2 pi, and we multiply it by the stretch or shrink factor, which in this case is 1 over 2. So our period in this case is going to be pi. And you guys will see with our adjusted coordinates that we will have a full cycle in the distance of pi this time. And we'll talk about how to scale our x and y axis in just a moment, but let's apply these changes to our coordinates. So again, I'm going to multiply all of our x values by 1/2 for that horizontal shrink. So we have 0, and then this will become pi over 4, pi over 2, 3 pi over 4, and pi. This will say 0, 3, 0, negative 3, 0. So if you look at how we might want to scale our x and y axis, it's good to, for our y axis, I think scaling by 1 is fine. So we can just leave it blank. If it is blank, I'm going to assume that it is scaled by 1. Now, if you look at your x values, I think a good way to scale our x-axis will be counting by pi over 4. So really just label 1, and I'll know that this is pi over 4, which makes this pi over 2, 3 pi over 4, and pi. So if we plot our points, we have 0, 0, pi over 4, 3, pi over 2, 0, 3 pi over 4, negative 3, and pi, 0. So this would be one full period, and you can see that it has completed a full cycle of its graph in the distance of just pi units. So again, this would be at pi over 2, this is 3 pi over 4, and this is pi, because we're counting by pi over 4. So again, this is just one full period, so we can actually do another full period to the left. So you'll notice that each tick mark, right, I'm either jumping up to a maximum, back to the midline, or to a minimum. So if I continue this pattern, here I'm in the minimum, or in the middle. So here I'm going to go down to the bottom, to the minimum. And then I go back to the middle, and then back to the top, and then back to the middle. So I'm kind of working my way backwards, but then you can see I have another full cycle of our sine graph. And you can see that I do continue a little bit past and draw the arrow to show that it is continuing infinitely to the right and to the left. Let's also add domain and range into this. So our domain is always going to be all real numbers. And then in this case, you can see that our range is from negative 3 to positive 3, including both. All right, so I have one for you to try on your own. Also, please include the domain and range of your function. So go ahead and pause the video and give it a try. All right, go ahead and check your work here. So you can see in this case, we have a vertical reflection. So of our y values, we're multiplied by negative 1. And we have a horizontal stretch by a factor of 2. So our x values were multiplied by 2, as well as our original period. So you do 2 pi times 2. And notice, although there's a negative out front, our amplitude is still positive 1. So remember, the negative and the a value are two different transformations. And then you can see I scaled my x-axis. I'm counting by pi. So it completes a full cycle, you can see, in 4 pi units. Okay, so using a table of values is good. However, it can be a little bit time consuming sometimes, and it's actually good to learn to kind of graph these types of functions using what I call logic. So just kind of understanding what the graphs are supposed to look like, understanding the period and the amplitude and just the general shape. So we're going to try graphing without using a table of values. So when I'm doing this process, where I like to start is I like to determine where the midline of our graph will be. So I kind of look for any vertical shifts up or down. And I actually sketch in a dashed line, a horizontal dashed line where the midline is. And then I look for an amplitude. And I use that amplitude to actually sketch in a maximum and minimum horizontal line as well. So I can kind of see where my graph bounces between. Then I look for the period of the graph, and I use that to help me scale my x-axis. So typically I take whatever the period of the graph is and I divide it by 4, so for the 4 quadrants. And then that kind of allows me just to bounce from the middle to the top, to the middle, to the bottom, to the top when I'm graphing sine. So this works really well about 90% of the time. Sometimes when there's an unfortunate phase shift, sometimes the units of the phase shift don't line up nicely with the units of the period. So I'd say about 90% of the time that works well, but you have to look at if you have a shift to the left or right, you need to consider that when you're scaling your x-axis as well. And then the last thing I really consider is the starting point, quote unquote, of our graph. So of course, since it's continuing infinitely from the left and right, there's no real starting point. But I call the starting point, from our parent function, I consider it 0, 0. So I just remember sine starts at the midline. So I'm going to start at our midline. And of course, if our graph is shifted to the left or right or up and down, that's going to affect our starting point. And then from there, again, I kind of continue my pattern of going up to the maximum, midline, minimum, and then midline. All right, so let's give this process a try. So remember, the first thing I like to do is kind of sketch out where my graph will be in terms of the middle, the max, and the minimum. So since I see that our graph has shifted up 3, I know that the midline of our graph will also be shifted up 3. So first of all, I'm going to maybe scale our y-axis differently. I'll scale it by 2. So our midline is going to be here at y equals 3. So that's our midline. Again, you don't have to do this. This is just something that I like to do. And then to help me figure out where the maximum and minimum are, I can look to the amplitude, which is right here. So since the amplitude of our graph is 2, that means that the distance from the midline to the maximum or the minimum is 2. So I can kind of sketch in my midline or my minimum value here. I know that my minimum value will be at y equals 1, and then my maximum value will be here at y equals 5. So I know that my graph will kind of bounce in between that max and the minimum. So now I need to determine the period so I can decide how I would like to scale my x-axis. So here I don't see any b values, so there's no horizontal stretch or shrink. So that means that my period is going to be 2 pi. So I think a good way to scale this graph, again, I usually take my period and I divide it into 4. So I think a great way to scale the x-axis is by pi over 2. Now I need to determine where kind of my starting point is. So I know that usually I start at the middle, which is right here. It's been shifted up because of the plus 3. And again, sine always starts at the midline, quote unquote starts. However, you can see that we also have this phase shift. So this graph is actually going to shift to the right by pi over 2. So that means that my starting point, instead of being here, is also going to shift to the right by pi over 2. So it's going to be right here. So this, I'll do my starting point in red. So this is kind of my starting point, okay? And then I know that sine goes from the starting point up to the maximum. So then I go up to here, and then back to the midline, down to the minimum, and then back to the midline. And since I've scaled the graph to be a period divided into 4, I know that I can just kind of bounce between these 4 quadrants and my graph will be accurate. So that's 1 full period, and then I want to graph 2 full periods, so I kind of continue that pattern going to the left. So I can go bottom, middle, top, bottom. So here I have 2 full periods of our sine graph. Just like this. And then we can see that our domain, again, is always going to be all real numbers. And our range is restricted. And it has changed due to 2 things. There's that vertical shift and there's the amplitude. So our range is between 1 and 5, which is another reason why I kind of like to sketch in that midline and that maximum. So it's easier for me to determine the range. All right, let's try another one together. So here I can start by looking for my midline. So I can see our graph has been shifted down 1. So our midline is going to just be here at y equals -1. And then I see that the amplitude of our graph is 1/2. Remember, the negative is a different transformation than the a value. The amplitude should always be positive because it's a distance. So that means that the distance from, again, the midline to the maximum should be 1/2. So it's going to be here at y equals negative 1/2. And the distance from the midline to the minimum will also be 1/2. So I'm bouncing between negative 1/2 and negative 3/2. So half a unit above or below our midline. Okay, now let's talk about our period. So I do see that I have a B value. So here I actually have a horizontal shrink by a factor of 1 over B. So to find the period again, I could start with the period of the parent function and I multiply it by that, the horizontal shrink factor. So again, it's always the reciprocal, or you could just do 2 pi over B. And I can see that in this case, our period is just 2. So notice now it's not in terms of pi, it's just 2. You will see that sometimes. So I think a good way to scale our y-axis or our x-axis could actually just be by 1/2 of a unit. So you could see, again, I take my period and I divide it by 4. So now I just need to think about my starting place. So again, sine always starts at the midline. Here I don't have any shifts, any phase shifts, so I'm going to just start right here. So again, my starting point I'll do in red just to kind of show. But again, there's not really technically a starting or an end point to these graphs, but that's just what I call it. Now the last thing to consider is that we have that reflection. So typically sine starts at the middle and then goes up first, but due to the reflection, I'm going to start at the middle and then I'm actually going to go down. So we go down and then to the middle and then up and to the middle. And then to the left, we can kind of continue the pattern, but going backwards. So then we have 2 full periods of our graph, just like this. And there you have it. And then let's also describe the domain and range. So negative infinity to positive infinity. And our range, as you can see, is negative 3 over 2 to negative 1 over 2. And there you have it. So if you're strategic about, how you scale your axes and kind of how you set up your graph, these are actually really easy to graph. But I think it's really good to kind of do that work ahead of time, of setting a midline, set a maximum and minimum. And then the rest is just jumping from your 4 quadrants. So following the pattern of middle, up, middle, down, middle. And of course, adjusting for any reflection you might see. All right, now I have one for you to try on your own. So please pause the video and give it a try. All right, go ahead and check your work here. So you can see due to the vertical shift, our midline is now at y equals 2. And then due to the amplitude change, our maximum is at 5/2 and our minimum is at 3/2. Because we have that horizontal shrink by 1/2, again, you take the original period, which is 2 pi, and you multiply it by the reciprocal. So our period is pi. So it's been shrunk horizontally. So you can see that I scaled my x-axis by pi over 4. Remember, I typically like to take my period and split it into 4 parts for the 4 quadrants. Here's my starting point, and then I just go up, middle, down, middle, and then a full period to the left as well. All right, now we're going to try one that's a little bit trickier. So you can see here we have that case where we have a B value and a phase shift. So we need to remember our first step should always be factoring out that B value. It needs to be separate. So we have negative sine times, so I'm going to factor out 1/2. So when I do that, it actually becomes x plus 2 pi. Right? If I do pi divided by 1/2, it actually becomes 2 pi. So if I look at this, well, let's start with our midline. I can see that we haven't shifted up or down, so our midline is just going to be at the x-axis. I can see that our amplitude is just positive 1, so our maximum will be at 1, our minimum will be at negative 1. I do see that we have a horizontal stretch by a factor of 2. So you take your original period and we multiply it by 2, so we get 4 pi. So in this case, I think a good way to scale our x-axis could be by counting by pi. But we do need to check with the shift that makes sense. Again, 90% of the time that works, but sometimes if the shift doesn't kind of match up nicely with those units, you may need to adjust. So if you look at what's happening here, we're actually shifting to the left by 2 pi units. So there's a phase shift to the left, 2 pi. So usually my starting point would be right here, but I need to start to the left 2 pi units, which if I'm counting by pi, will be right here. The last thing to consider is that we have that negative out front. So instead of going up first, we're actually going to go down first. Then we go 1, 2, 3, 4. So that's 1 full period of pi. Maybe I'll add an extra unit here. And I could do the same to the left. So 1, 2, 3, 4. Again, my x-axis is scaled by pi. So here we have 2 full periods of our graph. And there you go. I will also add in domain is all real numbers, and our range in this case is -1 to +1. All right, let's try another one together. So before I even start with the midline or anything like that, I am going to factor out that 2 pi. So we have f of x equals the sine of 2 pi times x minus 1 over 4, and then minus 1. So here we can see that we do have a horizontal shrink by a factor of 1 over 2 pi, and we have a shift to the right by 1/4. And then last we have that shift down 1. So let's start with our midline. So I'm going to say our midline is here at y equals -1. I could see that our amplitude is just 1. So we go up 1 for our maximum, which will be at y equals 0, and down 1 for our minimum, which will be at y equals -2. Again, for the period, right, it's a horizontal shrink by a factor of 2 pi, or 1 over 2 pi. So we multiply this by 1 over 2 pi, and so our period is 1. And our period does not always need to be in terms of pi. So perhaps a nice way to scale our x-axis is by 1/4, which actually works really well with our shift. Because remember here, we're shifting to the right by 1/4. So again, sometimes, the period and the shift, the units line up nicely, and every once in a while they don't. So sometimes you have to get a little bit creative or kind of estimate where their points will be. But this one, it works pretty nicely. I take my period and I divide it by 4. And then we need to talk about where our starting point is. So again, usually sine starts at the middle, but I do need to shift it to the right by 1/4. So now my starting point is going to be right here. And then I know that sine follows the pattern of middle, maximum, middle, minimum, middle. And you can see if I'm counting by 1/4, I have 1/4, 1/2, 3/4, 1. So you can say I do complete a full period in 1 unit. And I can continue that pattern to the left, just like this. And now I have 2 full periods of our graph. Let's add in our domain and range as well. So our domain is all real numbers, and our range is going to be from -2 to 0, including both. So just be really careful again. When you see that you have a b value and an h value, just make sure to always, always, always start by factoring out that b value before you do anything else. All right, I have this last one for you to try on your own. So again, please pause the video and give it a try. All right, go ahead and check your work here. So notice that the first thing I did was I factored out the 4. So it's 4 times x minus pi over 4. So you can see that we have a horizontal shrink by 1/4. So take your original period, multiply it by 1/4, and so the period is pi over 2. So you can see I scaled my x-axis by pi over 8. Now here we're shifting to the right by pi over 4, so instead of starting here, my starting point is here. And then I'm bouncing from middle to max, middle, min, max. And you can see that I have my midline at -2, my maximum at 1, because my amplitude is 3, so I went up 3. And then my minimum is at -5 because I went down 3 from my midline. And you see my domain and range right here. Okay, so that is all for today's video. Thank you guys for watching.